Hello, this is Dr. Hanaa Assil and this is paper 2CR, January 2021 of the Pearson Edexcel IGCSE Chemistry. So let's take a look at the questions and discuss the answers. So the first question here was, substances can exist as solids, liquids, or gases. Give the change of state that occurs when a substance melts. So if we have melting is what? It is the change from, you should know, melting is the change from solid to liquid. You should also know what is boiling, from liquid to gas at a specific temperature, condensation from gas to liquid, freezing from liquid to solid, and sublimation from solid to gas. Complete the word equation for sublimation of iodine. What does sublimation mean? If we say iodine is doing sublimation, that means it is changing from solid to gas. So you need only the state symbols here. The circle on the diagram represents a particle. Complete the diagram to show the arrangement of particles in a gas. How are particles arranged in a gas? Remember, they are very far apart and random arrangement, so you can draw particles so that they're not in any regular rows and they are far apart. None of them are touching. The table lists some statements about particles. Place ticks in boxes to show which two statements are correct for water particles. Now, you should know that water is a liquid state. So, in a liquid, which of these are correct? Particles only vibrate? No. Particles only vibrate if we're talking about a solid, so we would tick that if we're talking about ice. Particles do not move. That never is correct. That is never correct. The particles in any state are always moving. So if we say particles do not move, that's not right. Particles have no gaps between them. Now we're talking about a liquid, water. No, water particles or liquid particles would have gaps between them. Not all. Remember, in a liquid, the particles, some of them are touching and some of them are not touching. Particles move randomly. Yes, remember that particles move randomly in liquid and in gas. Particles have more energy than in ice. Yes, remember that energy increases from solid to liquid to gas. So the state that has the highest energy is the gas. This question is about elements in group 7 and their compounds. The table gives information about some of these elements and we are required to predict the color of fluorine at room temperature. You should be familiar with this. You should know that fluorine is a yellow gas. Chlorine is a green or yellow-green gas. Bromine is a red-brown liquid. Iodine is a gray solid. How many of the elements in the table are liquids at room temperature? So looking at these, how many of them are liquids at room temperature? Of course, to be liquid at room temperature, that means it should have low melting point, high boiling point. And you should know anyway that fluorine and chlorine are gases. Bromine is the only liquid, non-metal. We only have in the periodic table one other liquid, which is mercury, so that is the liquid metal. The other liquid is bromine, and that is the only liquid non-metal. Everything else in the non-metals is either gas or solid. The element astatine is below iodine in group 7. Predict the formula of a molecule of astatine. You should remember that all group 7, all halogens are diatomic. Diatomic means the molecule is made up of two atoms. So we have F2Cl2, Br2I2, and AT2. Seawater contains bromide ions. Bromine can be obtained by bubbling chlorine through a sample of seawater. The ionic equation for the reaction is this. So you know that chlorine is more reactive than bromine, so it can displace it. So if I say, for example, chlorine plus potassium bromide, so the Br minus there means there is something bromide, sodium bromide, potassium bromide. The chlorine is more reactive than bromine. It displaces it. And that means in this equation, what's happening to the chlorine? It is changing from Cl2 to Cl minus, from Cl2 to Cl minus. That means it is gaining electrons. Remember, all nonmetals, when they react, they gain electrons, and if they gain electrons, that means that is reduction. And you should know that the substance that is reduced is the oxidizing agent. Now what about the Br minus? It is changing to Br2. That means it's losing electrons. Loss of electrons is oxidation, and the substance that is oxidized is the reducing agent. Please remember. So here we're asking for oxidizing agent. The oxidizing agent is chlorine, since it gained electrons and it became reduced. The reaction occurs because chlorine is more reactive than bromine. Bromine is below chlorine in group 7. Explain the decrease in reactivity from chlorine to bromine. Remember, a non-metal is more reactive if it can take or it can gain electrons easily. So chlorine compared to bromine, chlorine can gain electrons easily. Of course, that is because bromine is a larger atom. As we go down group 7, the atom becomes larger, so there is less attraction forces between the positive nucleus and the outermost energy level where the electron is coming in. So bromine is bigger atom, less attraction to the electron that is being gained, so less tendency to attract the electron to the outermost energy level, so it is a less reactive non-metal. Of course, the opposite applies to metals. If we say which metal is more reactive, it is the metal that is more likely to lose electrons. But non-metals, the one that is more reactive is the one that is more likely to gain an electron. Elements in group 7 react with elements in group 1 to form ionic compounds. Which pair of ions both have electronic configuration 288? So we're looking at these, and you should realize that lithium, sodium, potassium, we have a choice between lithium and potassium. So lithium is something that has, or all of them are in group 1 actually, so they need to lose one electron. So is it lithium Li plus or K plus that would have 288? Remember, lithium atomic number 3, so that's just 2, 1. So if it loses the outermost electron, it's just 2. But potassium is atomic number 19, so when it loses the electron, it becomes 288. So my choice is K plus. Now, are we choosing between fluoride ion or chloride ion? Well, the fluorine has 9 electrons, so if it's going to gain an electron, it's just going to be 28. But chlorine, which forms chloride ion by gaining an electron, then it would be 288. Explain why metals conduct electricity but covalent compounds do not. You should realize that a metal is made up of regular rows of positive ions surrounded by delocalized free-moving electrons. So metals conduct electricity because they have delocalized electrons that are free to move, while covalent compounds do not. They do not have free ions and they do not have free electrons. Hydrogen chloride is a covalent substance. When hydrogen chloride is added to water, a solution of hydrochloric acid is formed. This solution does conduct electricity. Name the type of particle in the solution of dilute hydrochloric acid that allows it to conduct electricity. Remember which substances conduct electricity. These are free moving ions, positive and negative ions. Anything that has ions that are free to move would conduct electricity. The teacher uses this apparatus to investigate the electrolysis of a solution of dilute hydrochloric acid. The ammeter measures the current. So we have a syringe that has gas X, another syringe that has gas Y, and we're doing electrolysis of dilute hydrochloric acid. The teacher wants to find out if there is a relationship between current and volume of gas collected. She adjusts the power supply until the current is 0.1 ampere. After 5 seconds, she records the volume of gases in X and Y. The teacher repeats the experiment several times using a different current, and these are the results, and we are required to plot the results. So when we plot the results, we plot them with small x's. Now, draw a circle around the anomalous result. Remember, this result is a line of best fit. So the point that is away from the line, that is what we call the anomalous result. All the other points are almost on the same line. So the one away from the line, that is the anomalous result. Explain a possible cause of the anomalous result other than misreading the apparatus. So we have a point that is below the line. So that point was supposed to be higher somewhere. And this could be either the volume is less than it should be, so they're not reading the, taking the reading using the correct volume, or they're not taking it using the correct time. They're supposed to take the reading after 5 minutes. So obviously the student did not wait for 5 minutes and they took the reading before the correct time, or some of the gas escaped, so the reading is not correct. Deduce the relationship between current and volume of gas collected in syringe Y. So we have current versus volume, and as we see, it's a straight line, and that means it is directly proportional, or we say as the current increases, the volume increases. The ionic half equation for the reaction that produces the gas in syringe X is this, and the ionic half equation for the reaction that produces the gas in syringe Y is that. So just how these ionic half equations show that the volume of chlorine collected should be the same as the volume of hydrogen collected. Now, when we compare two ionic equations, add the two electrodes. First of all, we look at the number of electrons. If the number of electrons is the same, so the first one gives 2 electrons, the other one takes 2 electrons, then we can compare the number of moles or the coefficient of each gas. So obviously the first gas gives 1 mole of Cl2, the second equation gives 1 mole of H2, so the number of moles should be the same, and that means the volume of gases should be the same. So for the same number of electrons transferred, number of moles of chlorine is equal to the number of moles of hydrogen, and that is why their volume should be the same. Remember, if we're given 2 equations and the number of electrons are not equal, then we have to multiply one of the equations all through by a factor so that both equations have the same number of electrons, and then compare the coefficients or the number of moles of each of the products. So just why the volume of chlorine? So we already said that the volume of chlorine should be the same as the volume of hydrogen. So volume of gas in X should be the same as the volume of gas in Y. But the question says, well, suggests why the volume of chlorine in X is always less than Y. It's supposed to be the same, but it's always less. Now, why is that? We're talking, of course, about chlorine gas, and you should know that chlorine gas is soluble in water, so some of the gas formed at the positive electrode would be or would dissolve in the solution, and then the rest of it will go into the sewage. So if we're collecting chlorine gas, remember, chlorine dissolves in water, so some of it would be lost. This question is about alcohols, carboxylic acids, and esters. And the first question says, complete the table by giving the missing information. We are required to get the relative formula mass of ethanol. Do you know how to get relative formula mass? You calculate, we have 2 carbons. Each carbon has a mass number. Again, remember, we're talking about mass numbers. That's the big number from the periodic table. So carbon has a mass of 12, hydrogen has a mass of 1, and oxygen has a mass of 16. You add them all up, 2 times 12 plus 6 plus 16, that is an relative formula mass of, or what we call MR, 46. Now, what is the name of that third alcohol? This is an alcohol that has 4 carbons. Remember, when we name, we look at the number of carbons. This is 4 carbons, so the name should start with bute. This is an alcohol, so this is called butanol. Ethanol can be oxidized to ethanoic acid by heating with potassium dichromate and another reagent. How do we change an alcohol to an acid? Remember, to change ethanol to ethanoic acid, we have to heat it with potassium dichromate and concentrated sulfuric acid. This is the other reagent. We said we oxidize. Of course, this is an oxidation reaction. To change alcohols to acid, we use what we call acidified potassium dichromate, or it is potassium dichromate with concentrated sulfuric acid. State the color change that occurs. If we're using potassium dichromate, what is the original color of potassium dichromate? You should know that it's orange, and when it reacts, it changes from orange to green. So these are the colors of potassium dichromate. Alcohols react with carboxylic acids to form esters. Name the ester that forms when ethanol reacts with ethanoic acid. You should know that if we have an acid and an alcohol, when they react, they form an ester. And this is by joining the alcohol to the acid. Acids have C double bond OH at the end, so we remove the OH and we replace it with the part from the alcohol. Now, when we name that product, we start with the name of the alcohol. So this was made from ethanol, so its name would be ethyl something. It was made from ethanoic acid. That means it is ethyl ethanoate. That's how we name esters. Complete the equation for the reaction between methanol and ethanoic acid. Again, we have methanol. We're trying to react it with ethanoic acid, and you should realize that ethanoic acid, when we write it as a structural formula, it is written CH3COOH. Now, when it reacts, we remove the OH at the end of the acid and we replace it with the part from the alcohol without its H. So that part is the product, which is methyl ethanoate, and this is how we write it as a structural formula. So CH3CO, and instead of the OH we have OCH3. Of course, when you remove H and OH, then the product, the other product in the esterification reaction is water. Hydrogen peroxide solution decomposes slowly at room temperature to form water and oxygen, and this is the equation. A catalyst increases the rate of this reaction. State one other property of a catalyst. So we said catalysts increase the rate of the reaction and provides an alternative pathway that lowers the activation energy. So remember that a catalyst basically makes the reaction faster, increases the rate. Now, how does it increase the rate? This is by providing an alternative pathway, so the reaction happens in a different way with a lower activation energy. A student has samples of 3 solids, X, Y, and Z. The student uses this apparatus to find out which solids act as catalysts in the decomposition of hydrogen peroxide. So we have 3 solids, X, Y, and Z, and we want to know which one is a better catalyst or acts as a catalyst. Describe the method that the student should use to find out which solids act as catalysts. So that means we're going to put a specific amount of H2O2 into the flask. So for example, specify 25 centimeter cube of H2O2 into the flask. First, we're going to leave it without adding any catalyst, without adding any solid. So measure the volume of gas formed in a specific amount of time, for example, in 1 minute in the gas cylinder. Then we repeat using 25 centimeter cubed again of the H2O2 and 1 gram of X, for example, and determine how much gas in 1 minute. Repeat that with Y, repeat that with Z. And then we can filter the solution and weigh the solid. If it's a catalyst, you added 1 gram at the beginning, you should end up with 1 gram at the end. The decomposition of hydrogen peroxide solution is exothermic. On the diagram, draw and label the reaction profile for the reaction. Remember, reaction profile shows energy of activation. So if we're doing it without a catalyst, then the energy of activation is high. With a catalyst, we said the function of the catalyst is to lower the activation energy, so the height of that peak would be lower. The equation for the reaction can be shown using displayed formula. The table gives the bond energies for 2 of the bonds. Use this information to calculate the total amount of energy needed to break all the bonds in the 2 moles of H2O2. So if we look up there, what bonds are we breaking in the reactants? We have a bond between the 2 OHs in the H2O2, but we have 2 of that. We have 2 of the H2O2, and that means we have 2 times 2 of these bonds, so these are 4 bonds. And we have 1 OO bond for each H2O2. We have 2 of them, and that means we have 2 of the OO bonds. We have 4 of the OH bonds. The total amount of energy needed to break all of these bonds is 2,144. Of course, this is in kilojoules. Now, in the products, after the arrow, which bonds we need the total amount of energy released when all the bonds in the 2 moles of H2O are formed. So, where is the 2 bonds of the H2O? We have 2 bonds in 1 of the water, but we have 2 of them, so we have 4 times 463, that is 1852 kilojoules. Now, remember that here we are given the total delta H for that reaction, and we are required to calculate the O double bond O bond. We don't know what is the bond energy for the O double bond O. So the delta H is the total of reactants minus products. So reactants minus products is equal to minus 204. That means we can get what is X by rearrangement. X comes to be 496 kilojoule per mole. Question 6 says a student does a titration using dilute sulfuric acid to find the concentration of a solution of potassium hydroxide. The student adds 25 centimeter cubed of potassium hydroxide solution to a conical flask. He then adds a few drops of methyl orange. Of course, the student is doing titration. Name the piece of apparatus the student should use to add the potassium hydroxide solution. We need to add 25.0 centimeter cubed of potassium hydroxide solution into a conical flask. Of course, we use a pipette. What is the color of methyl orange in an alkaline solution? You are required to know the colors of methyl orange and phenolphthalein in different solutions. So in an alkaline solution, you should realize that methyl orange is yellow. Remember, alkaline means a base dissolved in water. So the color of methyl orange in base or in alkaline solutions is yellow. The table shows the student's results. So the students did the titration 4 times, and these are the results, and we are required to choose which of these are concordant. You should know that concordant results are the ones within 0.2 centimeter cubed of each other. So the difference between them should not be more than 0.2. Which of these are that close to each other? So 20.65 and 20.60, of course, these are very close to each other, and 20.55. But the 20.9 is way off. So that means that is a wrong answer, an anomalous result. We do not use it. And when the question says use the concordant results to calculate the average volume, we ignore the one that's not concordant. So we add up to get the average volume. You add the 3 of them and divide by 3. That means the volume needed is 20.60. This table shows the students' results for another titration. So they have the volume of potassium hydroxide used is 25. The concentration of potassium hydroxide is this. The volume of sulfuric acid needed is this. Now, calculate the number of moles of potassium hydroxide in 25 centimeter cubed of potassium hydroxide solution. So we have 25 centimeter cubed and we are given the concentration, so I can get the number of moles. Remember, number of moles is concentration times volume, and remember that concentration we're given 0.0370. The volume cannot be in centimeter cubed. I have to divide by 1000 to change it to decimeter cubed. This gives the number of moles. Then calculate the number of moles of sulfuric acid in this volume. Remember that we said when we have these calculations, the first thing is we use the information given to get the number of moles of one of them. So KOH, for example. Now we need to get the number of moles of the other one. I look at the equation. Can you see the equation? The equation says 2 of KOH reacts with 1 of sulfuric acid. So that means if I have number of moles of KOH, I need to divide by 2 to get the number of moles of sulfuric acid. Then now we have number of moles and we have volume. We're required to get concentration of the acid. Concentration is number of moles over the volume. Again, the volume is 21.20 centimeter cubed. So I need to divide that by 1000 first before I put it into the equation. And that means I can get the concentration of sulfuric acid in mole per decimeter cubed. A sample of gaseous hydrocarbon X has a volume of 600 centimeter cubed at room temperature and pressure. Calculate the number of moles of X. Now, if I have a gas and I have volume, how do I get number of moles? Number of moles is the volume over the 24. The volume has to be in decimeter cubed, so I need to divide that by 1000. And that means it is 600 centimeter cubed divided by 24,000 centimeter cubed. I have the number of moles of the gas. Then we're told that the mass of X is 1.45 grams. So what is the molecular mass? What is the MR? How can I get MR if I have mass and number of moles? Remember, number of moles is mass over molecular mass. So to get the molecular mass, it is mass over number of moles, and this comes out to be 58 as we are told. Hydrocarbon X is an alkane. Show that the molecular formula is C4H10. We got the MR to be what? The MR we got there in the calculation was 58. Now, if we say it is C4H10, is that correct? Yes, because the MR of C4H10 is 58. Give the displayed formula of the branched chain isomer of X. So, X is something that has 4 carbons, and we are required to draw the branching. Remember that the 4 carbons, you can either draw them all after each other. That is called a straight chain. But here he wants a branch chain, and that means we're going to draw 3 of the carbons all on one chain, and one of them is a branch. So remember, this is the branch chain of C4H10. This question is about ammonia gas. Ammonia can be prepared in a laboratory from the reaction between ammonium chloride and sodium hydroxide. Remember that we said test for ammonium was add sodium hydroxide, it gives ammonia gas. And we are told the other products of the reaction are sodium chloride and water. Give a chemical equation for this reaction. So we are already told we are reacting ammonium chloride with sodium hydroxide, and the products are ammonia, sodium chloride, and water. And you just write them as symbols. We need a chemical equation. That means it has to be simple, it has to be balanced. So we write the symbols and then you check, is it balanced or does it need balancing? Well, if you look at it, they're all balanced. The number of atoms before the arrow is equal to number of atoms after the arrow, so this is a balanced equation. Give a test for ammonia gas. What was the test for ammonia gas? Remember, insert damp. Testing a gas, you need damp red litmus paper. It turns to blue. In industry, ammonia is produced from nitrogen and hydrogen. And the equation is this, and you should actually remember that this is called the Haber process. In a sealed container, the reaction can reach a position of dynamic equilibrium. Remember, this is a reversible reaction, and that means the reaction goes both forward and backward until it reaches equilibrium. What is the meaning of equilibrium? Remember, dynamic equilibrium is rate of forward reaction equals rate of backward reaction, and concentrations of reactants and products remain constant. The graph shows the percentage yield of ammonia at equilibrium for different temperatures and pressures. Using the graph, explain if the forward reaction is exothermic or endothermic. How do we know that? You should realize that if the forward reaction is exothermic, that means when we increase temperature, the reaction should go backward. Remember, increasing temperature, the reaction goes endo. So if I increase the temperature, I get more ammonia, then the reaction is endo. I get less ammonia, then the reaction is exo. So when we look at this, as we increase the temperature from 350, 450, 550, the amount of ammonia is decreasing. That means the forward reaction is exo. Remember, increasing temperature, reaction goes endothermic. So if it's decreasing in the percent yield of product, that means it went backward. And that means that the forward is exothermic, since increasing the temperature decreases the percentage yield of the product. And that's the end of this paper. I hope this was useful to you, and thank you for listening.